All right, hey there, fellow coder. In this one, we're going to be diving into how we connect the 5 pillars of full stack development, which was the video that we had previously gone through. And we're going to connect this with the actual code that I used during the presentation where I created the web app from scratch in 5 minutes. So how this is going to go is we're going to start in the front end. Normally, I don't code first in the front end. When you saw my presentation, I started on the Java layer, on the Java pillar, if you will. But yeah, I think for explaining it, we'll just go from the front end all the way to the database. In the front end, we have our simple HTML page. HTML, CSS, JavaScript is what the front end is all about. In this one, we didn't have any JavaScript code. JavaScript is where you would add some more specialized functionality. If you want to refresh the page in real time, if you're clicking to add like a user and you want to immediately see them instead of having to manually refresh the screen, you could use JavaScript to fetch the data from the database and bring it into the screen and populate the users as they're added. Whereas in this application, when I added the username and password, I had to click on a button and it would refresh the entire page, and then you would see the extra user on the screen. So that's where JavaScript could help, is by making things a bit cleaner in terms of not having to refresh the screen. But having said that, this is our HTML code. The important bits are the fact that there's a form here, and the method is post. So if you remember back in our presentation, we were talking about, I guess I need to start the slideshow here to actually see. When we actually post, we're sending an HTTP request. So that, can I Alt-Tab out of here to go back to the code? Yeah. So when I'm actually doing the form post, that's what we're doing here. We're sending an HTTP request to that Spring Web layer, and we're doing a post, which will contain a header and a body. The body is made up of the inputs, right? So the input type text, input type password is what will be populated inside of the body when we send the request. Okay, so that's why I have these inputs here. So when you put inputs inside of a form and you have a way to submit it, that's what will send the post request and populate the body of the HTTP post request with the data that we need. So that gets sent over to the communication layer, which is Spring Web in this case. So let's have a look at what Spring Web does and where it actually exists. So Spring Web we have in our web package, and this is our controllers. So Spring, you can define a controller here, which you see it comes from the Spring framework. The controller is what listens to incoming requests. So just like in this chart, the communications layer will listen for the HTTP requests that are coming in from the front end. So the controller listens specifically using these guys, the get and post mappings. Okay, so get mapping, post mapping. It's listening to get requests and post requests, specifically HTTP requests. And what happens is it's listening on a particular URL. This is not obvious at what's going on here because we don't have a URL that's actually typed in here. But if we wanted to, we could say /users. And so the get mapping could be /users. So what that does is if we change our code this way, then we would have to go to localhost 8080 /users to be able to load this form. It would load the index file. Previously, we just went to localhost 8080 and that's it, with the sort of the root URL, if you will. And when we did that, it loaded up the index file because that's the path. The URL we were listening on was the root URL. So yeah, if we change it to /users, we can fire this guy up. Let me right-click on the application and say run. And then I will need to go into my, browser. Let me just make sure it fires up correctly. Good. So my browser is here. Let me go to, so if I go to localhost 8080, it's not going to work now. We're going to get a 500 error, or really I think it should have been a 404 because the page doesn't exist. What's the 500 error that we're getting here? Oh, it's saying user is not available on the request, which is interesting. I didn't imagine it would go to, I'm trying to think, where would that logic work? Because I would have imagined it would be a 404. Let's go to like /products because that doesn't exist. Yeah, see, that's a 404. If we go to /users, then it works, right? Where we see our screen that we're expecting. So there must be some default logic here that's left in that's listening on the root URL, which I don't know where that would be because I have a get mapping here and a post mapping, and I don't have any get mappings that are listening on the root URL. But yeah, somewhere in here in the logic, I'm sure there's a default that's listening on that root URL. Okay. Anyway, just wanted to show you when you listen, when you're using the get and post mappings, you can listen on specific URLs. So the point is, it's listening, and when it receives a request, a get or a post, it will take this request and route it or execute the code that is associated with this particular mapping. So this get mapping is tied to this method. This is the method that Java will run when it receives a get request on the user's endpoint. I guess that's or path, whatever word you want to use. They both mean the same thing. So it'll run this code. What does this code do? It has a model, also known as a model map, that will be populated with data. So this is part of something called MVC, Model View Controller. Okay, this is part of Spring Web on the other side of the equation over here, which you can't see with the common errors if I hit slideshow. That's this part where the communication layer, the Spring Web, translates the HTTP request into objects, into Java. Okay, that's the other half of this equation. Okay, the first part is this. It listens. This is, I love my students in my coding boot camp always like to make fun of me because I grab my ear when I say it listens. That's listening, and that's the first part, right? That's the front end talking to the communication layer, right? That's this code here, and it is expecting a. Remember when I was saying apples and oranges? It's expecting apples, but you're sending it oranges. This is where it will say what it's expecting, and here as well. For the post mapping, same concepts apply. It's listening on this URL with a post specifically, and this is what it is expecting. It is expecting a user object. If you don't send it a user object, that's when you're going to run into that 400 error, bad request. In this case, it's expecting a user here, but if you don't send it a user, it'll give you a bad request. So that's just, that's the first part of this front-end to communications layer process. If you do send it what it is expecting, okay, if you do pass it a user, or you do pass it, well, we're not actually passing a model here. Spring handles this in the background, so we're not actually passing anything here. But anyway, if that works, then it'll go over to the next step, which is the Spring Web talking to Java layer, which is here, where we translate an HTTP request into objects. And that's where we see this code here is what is doing that, right? The code here will take the request that's coming in and then map the values to a user object. How does it do that, though? How does it know how to map the data to the user? If we go to the front end, we have an input type text and an input type password. But look, we're using TH field. TH is something, TH comes from timeleaf. Timeleaf helps in this process of mapping a piece of data to the object that is created that is expected on the Java side. So there's a mapping that happens, and timeleaf is part of that, right? Now, it doesn't have to be timeleaf. This could just be JavaScript, right? It can be plain old JavaScript. It could be Angular. It could be React. It doesn't matter. There's a way to take data from the front end and map it to data on the back end. And as long as it's sent correctly, it will be translated into objects. Okay? So that is what happens inside of the user controller here. So because the user object has a username and a password, specifically these names, username, password, and because we have populated the model here, the model is populated with a user object, right? User is the key. This could be called anything. You can call this whatever you like. This is just a variable name. But the point is it's adding that user object to the model, which is what we are then populating. This word, the user word, is we used it right here. That's where this user came from. When I say user dot, I put the word user in there because I put it right here. So this word has to map to this word. Just like this word, which is users with an S, has to map to this word right here, users. So these mean something. I didn't just make these up and pull these out of thin air. These words map to what's on the model here, which is what Spring is all about, model view controller. And it's what is able to translate stuff back and forth here. translates the HTTP request into objects. That's what helps to do that. It's all about the mapping here, as well as the mapping here. So this sends the data as part of the response, okay? Because this is what we're returning a view here, and on that view will be populated this model. So this model will be sent to the view, which is part of the response. Okay, and the part where we're mapping from a request, not a response, is here, right? There's the request that comes in where we're translating it into an object, which is literally this code right here. We're taking data that came from a post and we're mapping it to a user object and passing it in here to do more stuff. So there's a lot of stuff going on here, and it's not explicitly defined here. We don't explicitly see the code. A lot of it is what's called, the word is abstracted away. The details are abstracted away, and Spring Web is what is doing the heavy lifting, right? Spring Web right here is what is abstracting away a lot of these details, and it just magically works under the covers. So what's next? Well, there's you can hit 500 errors, which we saw when we visited the root URL. We saw a 500 error because we were able to talk to the server, but then something broke on the server side in the response or whatever. So we got a 500 error. Now the next layer is Java talking to the communications layer that will talk to the database, which is Java talking to Spring Data. So where does that happen? Where does Java talk to Spring Data? Well, we have the controller, which talks to a service. Controllers should talk to services. That's just a good practice. Controllers talking to services, not directly to repositories. So this Spring Data layer is typically a repository. So it looks like Java should talk to a repository, but this is a simplification. The more unsimplified version is controllers talk to services, services talk to repositories. Okay, that's how we translate from the Java all the way over to the Spring Data layer, the communications layer. Okay, the service talks to the repository, and the repository is where the magic happens. This is where we extend something called JPA repository, which is part of Spring Data. JPA repository is part of Spring Data. Okay, you see where that mapping happens? That's where that magic happens. And again, there's a lot of abstracted away details here that you're not seeing, because all you're seeing is an interface. We're creating an interface in Java, calling it whatever we like. Excuse me. Typically, the convention is you name it the name of the domain object, which the domain object is called user, and then you add the word repository to it. So user repository. This could be product repository. This could be dashboard repository. I guess dashboard is not a good example of a domain object. I don't know. Transaction repository, account repository, profile repository, whatever domain object, whatever would be a database table, that's what the domain object would really be. What's happening here is we're extending something called JPA repository, and this is where the magic happens. This is where it unlocks all the CRUD operations that we are able to do. The creating, reading, updating, and deleting of data magically comes from this right here, which is beautiful. It's what allows me to be able to create this code in 5 minutes, create the entire full stack application, including a tie-in with the database, in 5 minutes. I wouldn't be able to do that otherwise without this code right here, without Spring Data. So because we have this code in the service, we can say, I hate that it formatted the code like that, we can say user repository .save. Where did this .save come from? I didn't create this .save method in the user repository. Remember, the user repository, if we look at it, just looks like this. It's just an interface. So where did that .save come from? It comes from the fact that we are extending JPA repository. That's what unlocks a lot of powerful stuff, because we can say user repository dot, and look at all the stuff we can do. We can find all with pages. So we can paginate the data. We have a count. We can count all the records. We can delete a single record based on a user that we pass in. We can delete all the records. We can delete them by ID. We can check and see if something exists. We can find by stuff, find by ID, find one specifically. We can save a bunch of entities. Like if we had a bunch of users, we wanted to save them all at once, we could do that. Anyway, it provides the CRUD functionality right out of the box without us having to do any heavy lifting other than creating a repository, which is beautiful. So the process of saying user repository.save or user repository.findAll is this right here. Java is invoking a CRUD operation. Java, this code here, is invoking the .save CRUD operation. .save is a create or update, right? It does one of the two things. I don't want to get into how it does one of those two things right now, but it's based on whether or not the domain object has an ID specified or not. If there's no ID specified, it'll create. If there is an ID specified, it will update. That's all the details I'll get into there. Or you can read, right? Find all, that's a read operation. You can do find one if you want to find a specific user, etc., etc. That's the read operations. That's just Java invoking a CRUD operation. That's what happens right here. Now, what happens on the other end? How does Spring Data then talk to the database and actually run SQL statements based on Java? That's what happens inside of the repository, right? The CRUD operations that we told it to invoke and carry out to talk to the database are all already prepackaged and built in, and someone else wrote that code. I did not have to write that code. Someone else wrote that code. If we wanted to be able to actually have our own scripts in here, you can use something called the query annotation. So you can do @query, and then you can say, okay, since I'm in the user repository, this is interacting with the user database table, or more specifically the users database table. But anyway, that's what we're interacting with, is the user table. You can return, it will be returning a user or a list of users, right? Depending on what your query is doing. So if we want to say, I don't know, if for some reason we wanted to find by username, no, yeah, you could do that. You could say find by username, and you could pass in a username. But then actually you wouldn't need the query annotation here, because this actually, I was using a common convention, which is find by and then passing in something, passing in a field that already exists. Let's say I want to not find by, but let me say I want to delete users, maybe just delete users or something. I'm trying to think of by password or something. I don't know. Why would you do that? That's a terrible example. And this wouldn't return anything. This would just be void. If you're deleting something, it doesn't return anything. But here, you could say query, and you could say delete from user. So you don't say users. Users was the name of the table if you go to the user object. The table name is users, but this is not we're not writing in a native SQL statement here. We're writing in something called JPQL, the Java persistence querying language. So you use the object name here, so the class name essentially. The class name. So you say delete from user, where password equals question mark or something like that, and then you can pass in a password here. So that's an example of, I don't know if this will work perfectly. I might have the syntax wrong, but I don't want to get into exactly how to get the right syntax and everything. But this is an example of what you could do if you want to have a custom query or custom. This isn't actually a query. This is invoking. This is doing an actual operation, not just querying. But which I think you might be able to. I'm getting too far into the weeds here. Anyway, I don't want to get too far in the weeds. You can do custom querying if you like, and that's what it looks like. Okay, but I want to comment this code out. Oops, swing and a miss. I'm used to my other shortcuts from. I use Eclipse a lot, so I tried to use Eclipse to. Anyway, doesn't matter. Okay, focus. That is an example of this part, running the SQL statements based on the Java code or Java execution invocations that were passed in. You can save, update, or say give me more rows or delete rows. So that's what happens inside of the user repository, right? That will actually interact with the database and do what it needs to do, and then it actually sends stuff back. So once you invoke it, so on the user service, right here, we've invoked the find all method, and that goes over here to the database and finds all the users, and then it sends back all the rows, which magically, the find all method, if I hover over it, come on, find all, show me them, try to hit, yeah, there. So it returns a list of users, or a list of user objects. Spring Data here, for interacting with the database, will do a lot of the heavy lifting. So Spring Data will communicate with the database to get the rows, and then once we get back here, the find all method over back here in this layer, the Spring Data will translate the rows back into Java objects, which is what we see here when we go to the find all, right? Find all, I don't want to click on that. The find all will turn the rows that it gets from the database back into a list of user objects. And this is Java objects. We're dealing with Java here, which is great. We want to be able to deal with Java because this is the Java method that we're working with, which returns or expects you to return a list of user objects, and it will, because automatically Spring Data does all the heavy lifting to translate it into Java objects, which is wonderful. Very rarely does this break for me. I don't think I've ever run into a problem with mapping. As long as you set things up correctly in the first place, it just works. It's like magic. I love it. And then we go backwards to here. The Java will send an HTTP response. So where does that happen? Let's go back to the controller. The controller, like I was saying here, this is where we return a response back to the front end. We say return index because we had a get mapping here, and it will return the view, which is the index.html file, as well as data inside of it. That's what's on the model, MVC, model view controller. Model is here. That's where the data exists, and the data is being passed back to the front end. The view is right here. We're saying return index, which is index.html. The view is right here. The view represents an HTML file. And controller, well, we're in the user controller right now. So that's model view controller for you, right? So that will send a response. When we say return index, we're sending the response back. So that gets handled by Spring. So the Spring Web will handle that because we are in Spring Web right now. We're dealing with a controller, which is Spring Web based. And then that goes back to here, and Spring Web will then send it to the front end, and the front end will receive that response. So that's where it will refresh the page and then execute the code here to do whatever it is it needs to do, to show whatever needs to be shown. Specifically in here, it will show an update of the number of users, because the users, if we just created one, will show another one in this users list, because that comes from the response. The response is populated with a model, which is populated with users, and it will, show that, because it will receive the response and show on the front end that data that was just passed to it. So that's what's going on here from front to back. I wanted to be able to explain all of my code. So the code I did not explain was the application properties. I said I cheated. I copy-pasted this in during my demonstration of how to create a web app in 5 minutes, or in 10 minutes or 6 minutes, whatever it was. I think it was 5 minutes and 45 seconds or something. I cheated and pasted this in. And my excuse was, you're going to have to type this stuff in somewhere with any language. You have to type in properties to be able to tell it how to connect to the data source. So this is just the code to connect to the data source. There's the URL, which we are using. This is very common in the world of Java. JDBC stands for Java Database Connector or Connection or something like that. I can't remember. And we're using a MySQL database, so this is the string for connecting to a MySQL database. And then this is the name of the database itself. We created a database called Web App Example inside of our MySQL Workbench. So this was the create database. Web App Example was a script we ran to create that database. And then this is how we connect to it. The username and the password, that's when I set up the database. When I set up MySQL, I set it up to have a username and a password to be able to log into the database and interact with the database. That's just part of MySQL, part of probably any database. You need roles, you need users, and the users have passwords to be able to give access to do stuff and interact with an actual database. So that's what you need there. This is Spring Data JPA. So this is which layer? This one, the comms layer over here. Spring Data, right here, requires some properties. So what we're saying here is for our Spring Data JPA code, so how, I should say maybe one more, so how the Spring Data layer here interacts with the database here, it needs to know, hey, what like language am I using here? They call it a dialect. So we're using the MySQL 8 dialect, because there are different versions of MySQL. There's MySQL 5.5, 5.7, or whatever, and 8. Right now, 8 is a common one and popular one, so we're using MySQL 8 dialect, because there's slight differences in how you would create a script in MySQL 8, in MySQL 8 versus MySQL 5.2 or 5.5. There are slight differences in certain examples. For the most part, they're identical, but there are some slight variants, which is why you need to be correct in saying my database is a version 8, so therefore Spring should talk to my database using the version 8 language. Okay, and then this just shows the SQL in here in the, it should show the SQL in the console. Okay, so this is just for helpful for debugging purposes. And then this I don't want to get into. This is how it will create the database and how it will handle the database when the app is shut down and restarted. Okay, there's a way to update is the most common one. This is what you would use in production, or you would use none in production, which means don't touch the database itself. Don't try to change the structure of it and all this stuff when I'm booting up my app. Typically I use update, but there's also create or create drop, which are very similar to each other, which means when you boot up the app, it'll delete the database and create a brand new database fresh from scratch. So you would only use this in dev when you're doing development locally on your computer. You would never deploy this to production. At least I've never seen that setting deployed to production. That would break everything and cause chaos and carnage and apocalyptic times. So don't do that. Use update or none in the real world, in production. Okay, so that's what the application properties file is that I did not talk about. And I didn't talk about this. This is just what you need to get started with a Spring Boot application. This gets automatically generated by the code that I ran in start.spring.io. So if you go to start.spring.io, you can quickly generate the skeleton of your app. So I chose Java, Maven, I typed in Coders Campus, and the artifact is just, you can call this whatever you like. I called it like web app in 5 or something like that. And I'm packaging as a jar, fine. I was using Java 17. You can use Java 8, which is very popular. 17 is the next long-term release, so I'm using that one. And you can add dependencies, right? So the dependencies I added were Spring Web. That's that first communications layer. We added Spring Data, JPA, which is the second communications layer. Java we already have. The front end, I use Timeleaf as a templating engine. And on the back end for the what you call it, database, I use SQL or MySQL, right? So those are the 4 dependencies that I added. Those are 4 of the 5 pillars in full stack web application development. That's where they came from, and then you can say generate. So there we go. I've now walked through all the code that I wrote and all the code I didn't write and explained it all as much as I could. Hopefully this little explainer video was helpful for you. I know it was still fast. There's still tons of detail that is left out here. Programming is not something that you learn in a year or 2 or 5. Programming is something that you are continually building on and learning about over your entire life. That's just what coding is all about. It is a lifetime journey, a lifetime of learning, a lifetime of making mistakes and learning from them and growing as a human being. That's what programming is all about. Hopefully you enjoy that process, because I very much do myself. So obviously there's tons I can't teach you because it's going to take you a lifetime to learn, but these are the building blocks. These are the foundations of coding and understanding how web apps function from front to back to front again. How we send messages back and forth. This is what programmers do day in and day out, all day. Okay, some programmers just focus on the back end. Some programmers just focus on the front end. Some programmers focus on the entire full stack. The people who are in most demand are the people who do the full stack, which is why that's exactly what I teach. Because my goal is to help you learn this stuff so you can turn this into a very rewarding and successful career and literally change your life and the life of you, not just you, but also potentially your family as well. That's what I've been dedicating the last 10, 11 years of my life. I don't even know anymore. I've been dedicating the last 11 years of my life to doing this. So hopefully you found this helpful. There's a ton of other videos that I have on YouTube. If you're watching this on YouTube, please feel free to check out the Coders Campus channel and subscribe if you haven't already. So thank you so much for watching. I look forward to seeing you in the next one. Take care, happy learning, and bye for now.